Teachers, welcome back to this video. And this video we're mainly going to look at how we deal with complex formulas. When we talk of complex formulas, we're talking about formulas which have more than one mathematical operators. In the simple formulas we have seen previously, we saw that we are dealing with only one mathematical operator. Now we are dealing with the formulas which have more than one mathematical operator. Let us see them on the computer. Thank you very much. Welcome back to this video. We are still looking at functions, and this particular part of the functions we are mainly going to look at how do we deal with the point and click functions, how do we make functions using point and click. Previously we've seen how we can deal with formulas by just writing them, but now we are dealing with formulas by dealing with pointing and clicking. Thank you very much. Let us go to the computer. Yes, fellow teachers, welcome to this first part of complex formulas. It is still also talking about formulas, but we are going to basically look at the complex formulas. A simple formula is a mathematical expression with just one operator, such as a plus, a minus, a multiplication, and so forth. A complex formula has more than one mathematical operator. It can have a plus, it can have a multiplication, and so forth. When there is more than one operation in a formula, the order of operation will tell Excel which operation to calculate first. In order to use Excel to calculate such complex formulas, you will need to understand the order of operations. This is the order of operations. The order of operation is just like we use body mass in secondary schools in mathematics, for those who study mathematics. Operations enclosed in parentheses or brackets are considered first. They are followed by exponential calculations. Those are the ones which have powers. They are followed by multiplication and division, whichever comes first. And lastly, they will be followed by addition and subtraction, whichever will come first. Now let us see how we can calculate a complex formula. In the example below, we'll demonstrate how Excel solves a complex formula using the order of operations. Here we want to calculate the cost of sales tax for an invoice. To do so, we will write our formula as D2 plus D3 times 0.075. Remember, we are writing the brackets first. Later we'll have a multiplication after adding up what is inside the brackets. In cell D4, the formula will add up the prices for our items together and then multiply the value which would have been got by the tax of 7.5%, which is actually the tax rate, the one which we've written by as 0.75, that is after dividing by 100 to calculate the cost of tax. Let us go and do it practically. We've said here we are going to write our we are going to multiply so that we can get, we are multiplying to get the unit cost. Even here, this one I just drag, it will give me the unit cost here. Now how am I going to get the tax? We are going to have the sum of these two, that is this plus this, and then you multiply it with the tax, which is actually 0.075. That is a tax of 7%. And then press enter. You're seeing that it's giving us a tax of 8.59. And after that, if I'm sending an invoice to someone, I can just add up all the costs involved in. That is, this is the total. That is adding D2 to D4, close the brackets. So the total cost will be $123.09. That is now what I'll write on my invoice I'll be sending. What I've actually written there is exactly what you see here. And then we are going on to a tip which tells us that it is very important to enter complex formulas with the correct order of operations. Otherwise, Excel will not calculate the results accurately. In our example, if the parentheses, that's the brackets, are not included, the multiplication is calculated first, and the result is incorrect. Parentheses or the brackets are the best way to define which calculation will be performed first. Let us have a level challenge, or try to open an existing workbook and create a simple complex formula. I've used the word simple, because these ones are still not that complex. They are complex, yes, but they are more complex formulas, far much complex than this. So create a formula which will have addition coming before multiplication. Thank you very much. Let us meet in the second part of this video. Welcome back. We are talking about functions, but this particular case we are going to talk about relative and absolute references. When you talk of relative references, they are references which actually change as you change cells, and absolute, those ones do not change when you change cells. Let us go and show it practically on the computer. Thank you very much. Welcome to this second part of this video. We are looking at relative and absolute cell references. There are two types of cell references. We have those ones called relative and those ones called absolute. Relative and absolute cell references behave differently when copied and filled to other cells. Relative references change when a formula is copied to another cell. However, absolute cell references, on the other hand, remain constant no matter where they are copied. They never change. Let us start by looking at relative cell references. By default, all cell references are relative references. When copied across multiple cells, they change based on the relative position of rows and columns. For example, if you copy the formula A1 plus B1 from row 1 to row 2, the formula will change to be A2 plus B2. Now, you're seeing that it has changed. Relative references are especially convenient whenever you need to repeat the same calculation across multiple rows or columns. Now, we are going to compare it in this example here you are seeing on the screen. To create and copy a formula using cell references, let us try to do it practically. Now, what you have been seeing on the screen is exactly what has been written here. The first thing we are going to do is to write our formula, which is equals, this is the total cost, this one times the quantity, which is our $80. That one is exactly what we see here. This $80 we are going to be seeing here. Now I can drag my formula, I can drag this formula downwards using the fill handle up to here. You are seeing that the prices have changed. But why do we see that the prices are changing in every row? They are changing because the formulas are different. The formula which is there is B2 times C2, while the formula which is here is B6 times C6, and this one here is B11 times C11. So it has changed depending on what we have been written in every cell. So such types of references are called relative cell references. So briefly, what is being explained here is exactly what I've tried to show you there practically. Now, we have tried, after getting our first answer here, we have tried to pull it down, to drag it down, and we have tried to see how it works. So briefly, if you see you need to read through this explanations here or the words here, you can pause the video and try to go through. But briefly, what I've talked about there in the illustration is exactly what has been written here. Now, if you double click the field cells to check their formulas for accuracy, it will be able to show you what you have written there. So the relative cell references should be different for each cell depending on their rows. For example, we said if I click here, it is showing that this is B7 times C7. If I click here, this is B7 times C7. Yes, if I clicked here, it is B9 times C times C9. So they are different for each cell. What about absolute cell references? When we talk of absolute cell references, these ones, there are many times when you do not need the cell reference to change when filling cells. Unlike relative references, absolute references do not change when copied or filled. You can use an absolute cell reference to keep a row and or column constant without changing. An absolute cell reference is designated in a formula by the addition of a dollar sign. We put a dollar sign before the column reference or before the row reference or before both. If you look at the example, in that example here, we are showing that here before A we have put a dollar sign and before 2 we have put a dollar sign. This means that the column and the row will not change when copied. If we put the dollar sign before 2, then the row will not change. And if we put the dollar sign before A, the column will not change when copied. You will generally use this format when creating formulas that contain absolute references. The other two formats are used much less frequently. In most cases we use this, but that will depend also on your work. When writing a formula, you can press the F4 key on your keyboard to switch between a relative and the absolute. It will always write that for you depending on what you want. This is an easy way to quickly insert an absolute reference. Now, we want to have a tax added to the other example we have seen there. In our example, we'll use the 7.5% sales tax rate in cell E1 to calculate the sales tax for all items we have calculated in previously. We'll need to use the absolute cell reference, this one in our formula, since each formula is using the same tax rate. We want that reference to remain constant when the formula is copied and filled to other cells. Now let us go and do it practically. The steps here are the same steps I'm going to explain here. Now this is now where we are going to have our cells, as we said previously. We are going to have this one times this one. I've got $8, but I want also to include tax. How am I going to include tax? I'm going to have I'll have this times this, but I want this one not to change, so I'll insert a dollar sign there and another dollar sign here. So E1 will not change, though D3 will be changing. You are seeing here it is relative, but here it is absolute. When I press enter, the tax is going to be 0.60. So if I was to drag this down, all of them up to here, you are seeing that the taxes are different. Here the taxes are the same, here they are also the same because the cost is the same. And when we check it here, if we come back here, you are seeing that it is D9 times E1. E1 hasn't changed. If I go here, it is talking about D6, but still this one is E1. If I go here, it is D12, but this one is still E1. So it is not changing. So here I've got tax. The tax rate is the same. The tax rate is the same. Now, what I've been trying to explain there is exactly what is being talked about here. Now, this is we're going to have a level challenge here. Open an existing Excel workbook. Create a formula that uses the relative references. Double-click a cell to see the cooperative formulas and relative cell references, and create a formula that uses the absolute reference. Thank you very much. We'll start from there in our next video.